Here's a quick review for you of exponent rules for Unit 7 in Math 8. Very first rule that we came across was product of powers, which stated that for any values that have a base that is the same, we can accept those values as 5 times 5 times 5 as an expanded form, and 5 times 5 times 5 times 5. We recognize that this is just a continued pattern of 5 times 5, 7 times. The product of power rule states that for the product of any two numbers having the same base, we can simply add the exponents together, as long as we're having the product of powers, meaning multiplying two powers that have the exact same bases. Next thing we talked about was quotient of powers. Similarly, the bases must be the same. If we talk about 5 to the 4th power divided by 5 to the 3rd power, we recognize that as 5 times 5, 4 times, and 5 times 5, 3 times. Whoops. And as we do this division, we recognize that 5 divided by 5 equals 1. Many people will simply just cross these out and say cancels. I prefer not to do that because cancellation sometimes suggests that it's going to be equal to 0. I want you to remember that any number divided by itself is 1. And what that ultimately tells us is that this is 1 times 1 times 1 times 5 over 1, or just simply 5 to the 1st power. The quotient of powers tells us that when dividing two powers with the same base, we can simply take those two powers and their exponent value and subtract the denominator from the numerator to get the exponent value. It does not matter if there's a positive or negative in either one of these. It is always the denominator from the numerator. Third one we talked about was power of a power. I would like to recognize that this will look something like this. Some value raised to a power. This value will be another power inside of here. I would like for you to remember that this power then becomes the base of this new power outside of the grouping. What this suggests to us is that we're taking the base times itself, the number of times that the exponent is written out here, hence the name power of a power. We recognize that this is still 5 to the 3rd power times 5 to the 3rd power, with the understanding that a product of power rules tells us that when the bases are the same underneath the product of powers, I can add the exponents, leaving us with 5 to the 3rd plus the 3rd, or 5 to the 6th power. The way that the power of a power is written is we take any number raised to a power that is then again raised to another power will be written as 2 to the exponent times the next exponent that's there. This would be for any number of values that are there. If we were to look at this and see a greater value inside of here, such as 2m raised to the 3rd power, we would recognize that there's a product inside of here, but we would still follow the same things. 2 times m times 2 times m times 2 times m, recognizing that we have 2 to the 3rd power times m to the 3rd power, or 8 times m to the 3rd power. This one right here is a little bit different. This is what we call the power of a product. This one was not mentioned much in this Unit 7, but it is something that you need to be aware of. The next thing we talked about was the 0 power. Under the 0 power, it's very helpful to remember that when we talk about exponent rules, we talk about 5 to the 4th power, we recognize the greatest common factor of 1 in all these numbers, and we recognize that all exponent values are 1 times the base as many times as the exponent says. So 1 times 5 times 5 times 5 times 5. When we understand this value of 0 power, we continue to look at this as a progression that is decreasing in those powers of the base. And we can see that that progression, as we go down to 5 to the 0 power, we're decreasing by 1 power of 5 because we're 5 times smaller. 1 times 5 is 5, and 5 divided by 5, 5 times smaller, would simply just be 1, because we're taking 1 times 5 0 times. So we're actually not even multiplying by 5 at all. We're simply left with the 1. It's a simple way to think about this. The way that we see this in math is we see anything, any number raised to the 0 power is equal to 1. Next, we saw negative exponents. And what we need to really be thinking about right here is reciprocal. A reciprocal is not a negative exponent. I want to make that very clear, that a reciprocal is the inverse of a number that we see. When we talk about this value, if we were to continue the value of what we saw in the 0 power, constantly dividing by 5 over and over, we can continue that pattern of dividing by 5 to help us recognize that 1 divided by 5 would be 1/5. What we should moreover recognize is that it's this way. If we have 5 to the negative 4th power, we should instantly be thinking about the reciprocal of the base. The reciprocal of the base, we need to be thinking the opposite of multiplication. So we need to be talking about the multiplicative inverse of 1/5 being raised to the 4th power. When we apply this power as a power of a power, we recognize this to be 1 to the 4th power divided by 5 to the 4th power, or simply 1 times 1 times 1 times 1 divided by 5 to the 4th power, which would be 625. We can recognize that this value of 5 to the 4th power is also the same as 1/5 raised to the negative 4, or raised to the positive 4th power. It is acceptable to also write this as 1 divided by 5 to the 4th power. If you are asked to calculate, we would then take it to 1/625. The last value that's given, or the last rule that we talked about, is is the exponent product rule. What the exponent product rule talks about is numbers with different bases having the same exponent can be recognized under a law similar to distributive law, that we have two values or two bases that are both being multiplied by the same power. When we talk about whether they're both being raised to the same power, when we recognize that 5 and 2, the product of 5 and 2, we see that as 5 times 5 times 2 times 2. We can group these and see that we have 5 times 2, 2 times. The exponent product rule can only be applied, again, when we have multiplication. That's why we see product. And then when we see the exponents are exactly the same. We see this as written as a to the n power times b to the n power is equal to the product of a times b raised to the n power. There's a quick review for you of the exponent rules. Hopefully this is helpful. Reach out if you need more, if you have more questions and need more help. Take care.